Good evening, everyone. So I think it's the which number class? Third number lecture, right?
Yes, sir.
Third or fourth? Motional EMF. Third lecture. So now we know, first of all, magnetic flux, that is integration of B dot S, which is Bs cos theta. So flux depend on, we know its SI unit is Weber. This magnetic flux depends on magnetic field, cross-sectional area, and the angle between magnetic field and area. This is the first one. Number two, by using Faraday's law and Lenz's law, we know induced EMF minus d phi by dt. And the third one, by using motional EMF, we know EMF is BLV. And if it moving with some angular velocity, so induced EMF is half B omega L square. এতখানি তো পড়েছিলাম নাকি? এগুলো পড়েছিলাম তো? হ্যালো?
হ্যাঁ স্যার, সে টাইপ 3 পর্যন্ত করিয়েছিলেন। তারপর 9টা নিউমেরিক্যাল দিয়েছিলে যেখানে ম্যাগনেটিক ফিল্ড বার করতে বলেছিলেন।
Okay. So before we start, I just want to share just one more thing. We know from the last class in presence of magnetic field, if we in presence of magnetic field, just give me some time. If we introduce a rod whose length is L, moving with angular velocity omega, this is the one thing. Second one, if we have n number of rods like this, moving with angular velocity omega, suppose the same length L, or if we have an infinite number of rods which is look like a disk, angular velocity omega, in all this case the induced EMF is half B omega L square. So if you get a rod, or if you get this type of things, or if you get this type of things, so in this type of situation, your induced EMF is half B omega L square. Is it clear?
Yes, sir.
Okay. Now I'm moving to the next part. We try some numerical today. So first, type 1 numerical. Type 1 numerical. Okay. So my first type of numerical is, yes, infinitely long current carrying conducting wire carrying current I, and a rod is there. Let the length of the rod is L, which is moving with velocity V, which is at a distance A from the rod. Question is that find induced EMF on the rod. So you can try this question. I give you some time for that. I'm stopping. Anyone tell me what is the answer? Anyone? See, So let a small elementary part dx, which is at a distance x from this one. So for that small elementary part, we know induced EMF B dx V. So what is my magnetic field for that infinitely long current carrying conducting wire? Mu naught I by 2 pi x dx B. So we can write it. We can write it mu naught I V by 2 pi dx by x. Now taking integration both side, this is 0 to EMF. That is mu naught I V by 2 pi integration of dx by x from this end A to this end, that is A plus L. Everyone, yes or no?
Yes, sir.
So my induced EMF is mu naught I V by 2 pi log x base E. Numerical করার জন্য এটা খুব সুন্দর, কিন্তু theory when you have some direction, এটা দিয়ে অত সুন্দর direction দেখানো যায় না, especially 3-dimensional direction হলে. So we can use EMF equals to mu naught IV by 2 pi log A plus L minus A, sorry, log A base E, that is mu naught IV by 2 pi log A plus L by A base E. Yes or no?
Yes, sir.
Okay. So the next question. সবাই বুঝেছি সেটা? Everyone, is it okay?
Yes, sir.
So let's move on to the next part. Type 2. Type 2. In type 2, same type of question, infinitely long. Infinitely long current carrying conducting wire, but here it's a semicircular loop. This is the center. Let the distance is A from here, and let the radius is R. Same question, moving with the velocity V. Same question, find induced EMF. So in this question, again, the same way, first we can find out a small elementary length dx, which is at a distance x from the rod. So my induced EMF B dx V. Now B is mu naught I by 2 pi x dx V, which we can write mu naught I by 2 pi V dx by x. So when we calculate the total EMF, only my integrations a little bit, means the limits a little bit change. Mu naught I 2 pi V integration of dx by x. But now I can start from that point. This is my A minus R lower limit, this point, and obviously we know velocity vector and length vector are perpendicular. So A plus R, this is my limit. So what I can write here, my lower limit A minus R and upper limit A plus R. সবাই বুঝতে পেরেছিস?
হ্যাঁ স্যার।
So my induced EMF is mu naught I V by 2 pi. সবাই একটু একটু রেসপন্ড দিস, নাহলে বোঝা যায় না বুঝতে পারছিস কিনা। A minus R, A plus R. So my induced EMF mu naught IV by 2 pi log A plus R base E minus log A minus R base E okay, video off করা আছে না? So what we can write? We can write mu naught I V by 2 pi log A plus R by A minus R base E. Clear everyone?
Yes sir.
So if you want to note or if you want to take a screenshot, you can take it. Type 2. Everyone done?
Yes sir, done sir.
Yes.
Very good. Next I show you type 3. Type 3. See, in type 3, suppose this is my magnetic field. I know that if this is my rod of length L, one point is fixed O, and it is moving with the angular velocity omega. So my induced EMF is half V omega L square, type 3. Okay. Now what happened? Examiner give you a little bit, they change it a little bit. How they change it? I just want to show you. This type of questions, at least 2-3 times asked in examination. They take a rod like this and they take center this one. This is your A and this is your B. So at the same time, both are moving. So in that type of situation, my induced EMF is, see if this is moving in this way, it is moving up. It is moving up, so it is moving down at the same time. So my induced EMF is half V omega A square minus B square. Got it? Like এটা যদি পজিটিভ হয় এটা নেগেটিভ হবে, এটা এদিকে যাচ্ছে এটা এদিকে যাচ্ছে. Yes or no?
Yes sir.
So the answer is half B omega. মানে at the same time এটা যখন উপরে যাচ্ছে same time এটা নিচে যাচ্ছে. That's why it will be reverse. Okay. Now type 4. What happened in type 4? Type 4. The examiner give you an infinitely long wire carrying current I, and there is a rectangular loop A, and this is B. And question is that which is at a distance, suppose R, from the wire, and question is that find total flux in the rectangular loop. So in this type of situation, again, first of all, we have to imagine elementary part. let the thickness is dx, which is at a distance x from the current carrying conducting wire. So my change in flux, the formula is integration of b dot dx. Oh, sorry. Small, no need for integration. B ds cos 0. So B ds. So B and ds. What is that area? B into thickness is dx. Is it clear?
Yes, sir.
And how you get the magnetic field for infinitely long conducting wire? Mu naught I 2 pi x B dx from magnetic field due to current. So overall we have mu naught IB by 2 pi dx by x. So my total flux, taking integration both sides, mu naught IB by 2 pi integration of dx by x from R to that length, mane R to R plus A, yes or no? So my total flux mu naught IB by 2 pi log x base E R to R plus L. So what happened? Mu naught IB by 2 pi log R plus A minus log R base E. That is mu naught IB by 2 pi log R plus A by R base E. That is, you can write mu naught IB by 2 pi log base E 1 plus A by R. Yes or no?
Yes, sir.
Okay. After that, is it okay, everyone? Type 4.
Yes, sir.
Everyone, is it okay?
Yes, sir.
Okay. Next, I want to show you two questions from the sheet. I'm just going to sheet ta pathai ni na এখন পাঠিয়ে দেব sheet. Type 5. Look at this question asked in IIT. See the question. Beautiful question. The question is that this is a magnetic field. In presence of this magnetic field, a rectangular wire like this এই তো ঝামেলা হয়ে যাবে, জানতাম এটাই হবে। হ্যাঁ, This is the P point. This is the Q point. This is O point. This is S point. This one is A. This one is C. And the resistance is 3 ohm, 3 ohm, 3 ohm, 3 ohm, 3 ohm. The length of this one is 10 centimeter. Moving with velocity V. Now see what is given. This wire, this rectangular wire, the resistance of this rectangular wire, you can name it also PQRS. TV, suppose we are framing it. So resistance of PTVO, that is given 1 ohm. Resistance of PQ and OS, this is what you say, good conductor, that means negligible resistance. I just want to read the question. A rectangular metal wire loop of side 10 centimeter and resistance 1 ohm, means that rectangular loop or square loop, the resistance is 1 ohm. Okay, resistance is 1 ohm, is moved with a constant velocity V in a uniform magnetic field, B, that is 2 Weber per meter square. 2 Weber per meter square, as shown in the figure. The magnetic fields are perpendicular to the plane of the loop, directed into the page. The loop is connected to a network of resistance, each of value 3 ohm. The resistance of the lead wire OS and PQ. Lead wire means they are very good conductor. Okay, lead wire, the resistance of the lead wire OS and PQ are negligible. Meaning no resistance is there. Okay, what should be the speed of the loop so as have a steady current of 1 milliampere in the loop? So what is the speed so that in this loop the current is 1 milliampere? What is the speed? This is the first question. And second question is, give the direction of current in the loop. Everyone, is it okay? You understand the question?
Yes.
Hello? See, the question is that, okay, this is my rectangular loop whose resistance is 1 ohm. Okay, the whole, this one is moving with velocity V. We have to find out this velocity. The current in this loop is 1 milliampere. The magnetic field is 2 Weber per meter square. Length of this one is given 10 centimeter because that part is outside. So don't need to find out the magnetic field of this one. Only we can find out the magnetic field for this wire, which is moving with velocity V actually. Now see, if I try to find out the second part first, as the loop is moving outside from the magnetic field, that means my flux is decreasing, yes or no?
Yes, sir.
And as my flux is decreasing, so what we can say, as my flux is decreasing, according to Lenz's law, induced EMF will try to increase it. So induced EMF will try to increase it by inducing the current. So current will produce in the opposite direction of the magnetic field. So here the magnetic field is given cross. So the current produced in this loop is dot. Yes or no? And yes, what do you mean by dot? Current is dot means anti-clockwise. Yes or no?
Yes, sir.
Right hand curl rule. So anti-clockwise, that means the current will flow in anti-clockwise. So I first give the second part. The current is anti-clock. Yes, everyone?
Yes, sir.
Now, I want to show you the velocity. For what velocity? So for that, first of all, I have to find out the EMF, that is BLV, we all know. Achha. Now, clearly, see, in the one diagonal, you have an equivalent. In another diagonal, you have a resistance. So I can say this resistance by this resistance by this resistance. So yes, it will satisfy the balanced Wheatstone bridge. And as it will satisfy the balanced Wheatstone bridge, I can remove AC from the circuit, yes or no?
Yes, sir.
So I'm just removing it, but I put it here so that you are not confused. It is there, but due to the Western bridge, I'm removing it from the circuit. So 336, 336, 66. So resistance of QS is 6 into 6 by 6 plus 6. That is 3 ohm. So my total resistance is 1 plus 3. That is 4 ohm. Yes or no?
Yes, sir.
So I know the value of the current is induced EMF by resistance. My current is 10 to the power minus 3 ampere, that is 1 milliampere. Motional EMF magnitude is given, that is BLV by R. Magnetic field is given 2. Length is 10 centimeter, that means 10 to the power minus 1. Velocity I want to know, and resistance is 4. I can cancel it. So my velocity is 2 into 10 to the power minus 3 by 10 to the power minus 1, which means V equals to 2 into 10 to the power minus 2 meter per second, that is 2 centimeter per second. Yes or no? Bhalo question chilo na?
Yes, sir. Interesting.
Acha. I show you one more interesting question. That question also asked in IIT. Question. If you want to take a screenshot, you can take. এটাকে আমি যখন পিডিএফ এ কনভার্ট করছি একটা পেজে আসছে আধা লেখা উড়ে যাচ্ছে।
হ্যাঁ স্যার ওয়ান নোট ট্রাই করলে একটা পেজেই আসবে স্যার।
না আসবে, অন্যরকম ঝামেলা করতে হবে, টেক্স টাইম। একটা পেজে না আমি অন্যভাবে করলে আসবে, কিন্তু ওই হ্যান্ড রিটেন নোট পাঠিয়ে দেবো, লেখাও হচ্ছে না রে। আমি একটু যদি সময় পাই, এটা শেষ হবে, আমাকে এখন খাতা দেখতে বসতে হবে, আজকে আমাকে কালকের মধ্যে শেষ করতেই হবে। ওকে, টাইপ 6, last question for today. That is also IIT question. In IIT, this question also asked a lovely question. Dekho. So electromagnetic induction and magnetic field. This is the you can say in terms of entrance point of view, one of the favorite topic. Electromagnetic induction and magnetic field. They punch them and give you the question. See, the next question. The question is that magnetic field is B. Magnetic field is B. This is the region 1, region 2, sorry. Region 2, and this is region 1. This portion is field free, means magnetic field free, and this region is with magnetic field. Okay, and here a semicircular ring is present. A, this point is O, this point is D, C, moving with angular velocity omega. The radius is R. Now, what is the question? Okay, I just want to read the question. Space is divided by the line AD. You can see by the line AD. Okay, into two regions. Region 1 is field free. You can see clearly region 1 is field free, and region 2 has a uniform magnetic field, capital B. You can see this. Okay. Directed into the plane of the paper. You can see this. ACD is a semicircular conducting loop. ACD is a semicircular conducting loop of radius R smaller with center at O. The plane of the loop being in the plane of the paper, the loop is now made to rotate with a constant angular velocity omega. You can see this also about an axis passing through the O and perpendicular to the plane of the paper. That means this is the axis which is perpendicular, upward, so that can be rotated like this. So how it will be rotated? It will be rotated like this. Sure. Like কি করে লোকে এগুলো দিয়ে পেইন্ট করে ভগবান জানে, আমি তো শালা ধরতেই পারি না। Okay, this way it will be rotating. Understand everyone?
Yes, sir.
About an O and perpendicular to the loop of the paper, the effective resistance of the loop is R. So in this ACD, the resistance of the loop is R. Now the question is that number one, the expression for the magnitude of the induced current in the loop. So first you have to find out the expression for the magnetic field in the loop. That is the first one. Second one, show the direction of the current when the loop is entering into the region 2. When it is entering into the region 2, show the, एक minute, I think I made a mistake. इसमें हमने करंट क्या बोला? क्रॉस बोला ना? हेलो?
Yes, sir.
तुम लोगों ने देखो, मुझे कोई नहीं बोला. The rectangular loop is moving inward or outward? मतलब बाहर जा रहा है कि अंदर जा रहा है? चलो, flux is increasing or decreasing? Anyone please respond. Flux is increasing or decreasing?
So decreasing.
Decreasing. So if the flux is decreasing, so induced EMF will try to oppose it. माने decrease और उसको increase करना चाहेगा, तो cross के लिए cross होगा ना? अरे decrease हो रहा है, how can make it increase? उल्टा करके, मतलब cross को cross करेगा. So I'm very sorry. ये क्या हो जाएगा cross? What do you mean by cross? ये clockwise होगा. हाँ, by mistake. मेरे को भी दिमाग में नहीं था, तुम लोग भी नहीं बोला. Sorry. This is clockwise. Now it's okay. Here. Now, as in this one, second one, show the direction of the current when the loop is entering into the region 2. And third, you have to plot a graph between the induced EMF and the time. Induced EMF versus time. Time of rotation for 2 period of rotation. माने 2t तक. So we see later on. सबसे पहले देखो, as that one is entering, so as it will be entering, my area will increase, and as the area will increase, it will try to decrease it. So cross का उल्टा dot माने anti-clockwise. माने current जो produce होगा dot produce होगा, मतलब magnetic field जो है dot produce करेगा. Yes or no?
Yes, sir.
अब देखो इसको, अगर तुम लोगों को याद है, मैंने बोला था, whenever you have this angular velocity type of question, you can directly write induced EMF is half b omega L square. Sorry, not L, R. Radius is R here. So you can write directly induced EMF b omega R square. If you write directly, so then the current is induced EMF by resistance. So I can write b omega R square by 2R. Yes or no? First part done. Yes, everyone satisfied? लेकिन अगर कोई बोलेगा कि सर आप ऐसे कैसे बोल सकते हो, यहाँ पे प्रूफ करके दिखाओ, तो आई कैन डू दैट, नो इशू. देखो ये जो है, मानो फॉर ए इंस्टेंट ये इतना अंदर गया है, धीरे धीरे जा रहा है ना, फिर धीरे धीरे ये आएगा, फिर धीरे धीरे ये आएगा, देन ऐसे करके पूरा अंदर आएगा। तो ये जो अंदर गया है, so if I am talking about this part, small part, this radius is r, this is the arc length, ds, that is r d theta if theta is my angle. So how we get this area, TL ले लो ज्यादा अच्छा रहेगा, otherwise we are confused. DL, so ds is half r into dl, if you remember, half r into r d theta. So what you have, half r square d theta. Remember this elementary part for a small arc length? Yes or no?
Yes, sir.
So I'm talking about that part. I'm talking about that part. So if I want to calculate the change in flux for that part, change in EMF for that flux, change in flux, sorry, magnetic field into area ds. Magnetic field, my ds area is half r square d theta. So my induced EMF is d phi by dt, that is half b r square d theta by dt, which is half b r square omega. देखो मैंने पहले ही ट्रिक बता दिया था, इतना आएगा। ये सब लो। हाँ, और देखो ये मैंने कहाँ पे बताया था, ये देखो एकदम शुरू में बता दिया, ये देखो बोला था ना। देखो डिस्क के लिए भी आएगा, क्यों? क्योंकि अगर डिस्क भी अगर ओमेगा रोटेशन कर रहा है तो इसका भी अगर हमें स्मॉल पार्ट चाहिए तो हम ऐसे ही निकालेंगे ना। ये सब नो, एक रॉड के लिए भी यही हो रहा है, इसके लिए भी यही हो रहा है। यस
यस सर।
So I can write it directly also. If you have time, you can derive it. If you remember, you can directly do that. कुछ नहीं नंबर कटेगा। They तो just want you the current का expression. कहाँ से current का expression मिला तुमको थोड़ी चाहिए। They just know to confirm that you know this one or not, because they just want you to find the expression of current. So you can write this directly. So once you get this one, so I can say my current is EMF by resistance. So B R square omega by 2R, that is my current. So the second part also done. Second part also done. Second part also, sorry, first part done, second part done. Now the third part, the relation between current and time period. See, when it moving from here to this one, it will take T/2 time, and again it will be moving out. So if this is my first position, this is my second position. So from first position to second position, it will take T/2 time, again coming back to the first position. So my time will like 0 to T/2, from first position to second position, T/2 to T, second position to first position, T to 3 T/2, first position to second position to first position, 2T. Yes or no? Goal করে ঘুরছে?
Yes sir.
So if I want to calculate the EMF versus current, EMF versus time. So my time is 0 to T/2, T, 3 T/2 and 2T. What I realize that 0 to T, suppose my EMF is this one, that is half B omega R square. When it is coming out from region 2 to region 1, it will be just the opposite, yes or no? In this one, suppose the flux is increasing, in this one the flux is decreasing, because in this one it will try to enter region 2 to region 1, region 1 to region 2, and then from this one region 2 to region 1, again the flux is increasing, again the flux is decreasing. Got it? This one?
Yes, sir.
বুঝতে পারলি এটা?
হ্যাঁ স্যার।
আমার তো মনে হয় বুঝতে পারিস না।
স্যার বুঝেছি।
এই দেখ, এখান থেকে এখানে আসছে region 1. So when it is moving from 1 to 2, so my flux is increasing, है ना? My flux is increasing, দেখ এইভাবে বাড়ছে। তারপর region 2 থেকে যখন আবার region 1 এ আসছে, আবার দেখ ধীরে 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 খালি হয়ে যাচ্ছে, আবার 2 থেকে 1 এ যাচ্ছে, আবার বাড়ছে, আবার 1 এ আসছে, কমছে। So in that way continuously what happened? কি যখন 1 থেকে 2 তে যাচ্ছে, when it is moving entering from 1 to 2, my area will increase, flux will increase, induced EMF will try to decrease it. Now when it moved from 2 to 1, my area decrease, flux decrease, induced EMF will try to increase it. So they are just reverse. So 1 to 2, 2 to 1, 1 to 2, 2 to 1, 2 time period. Dekho, this one is 1 to 2, this is 2 to 1, this is 1 to 2, this is 2 to 1. Clear everyone?
Yes, sir, clear.
So that's it for today. I'm stopping the recording.